when I was asked by Rob and Pascal and Sarah to give a talk on ethics and climate change, it was sort of a delight, but also a challenge. And I want to be very clear that I really don't know anything about ethics as a specialist, so don't mistake my comments. At the same time, I have been thinking about climate change for a while, and there are some ethical components that always come up, and I want to comment on a few of these things, but more provoke Dale, I hope. And one of the interesting things that Rob mentioned is that Dale, I read his paper recently, actually, on climate engineering, one of the topics I'm going to discuss today. Dale wrote a paper on climate engineering in 1995, which is extraordinary because almost nobody was thinking or talking about climate engineering in 1995. And what I want to do is start today, after I talk about some of the scientific concerns, look at that paper and some of the issues it brought up, and provoke Dale maybe for a bit of a discussion about the ethics of climate engineering and climate change more generally, and see where we go from there. I think the perception of the climate science has changed quite a bit, but we'll get there. First of all, most of you, I hope, know this figure. This is the lifetime achievement of Dave Keeling. He started measuring CO2 in 1957. It was 315 parts per million, and when he died in the summer of 2005, it was above 380 parts per million. It's an extraordinary achievement of one man. We're pushing 390 now. It's really unbelievable. When I was in graduate school, we talked about CO2 being 350. When I was teaching here at Princeton, we talked about it as 360. When I moved to Harvard, after a few years, I taught students that it was 370, and now it's almost 390. I mean, it's really going up fast. What this has meant, though, as a geologist, is I see that record differently. Again, I think about it, this is the Vostok and Epoca CO2 records. This is now CO2 over the last 650,000 years. And as a geologist, I see the Keeling record this way, which is in 2009, there we are. And people who are not climate scientists, often you can look at the record and say, so what's the big deal? It's gone up a bit. CO2 is higher today than it's been, at least from direct observations, for 650,000 years. And over the next 40, 50, 60 years, it will get to about 500 parts per million. It is almost unthinkable that it will not get to 500 parts per million. The discussion that we who work on energy technology and climate solutions think about is how to keep it from going higher than 500 parts per million. And that's what a lot of people don't understand about the climate discussion. It's not whether there will be climate change, it's how bad is it going to get. But the point is that CO2 has never been this high directly for 650,000 years, and indirectly, probably we have a variety of geochemical ways of measuring ancient concentrations of CO2, probably not for at least the last 35 million years has it been above 500 parts per million. So if you think that any climate scientist understands all the different aspects of the climate system in detail enough to make an accurate prediction of the future, think again. This is a problem that is inherently uncertain because that is the nature of the problem. We're doing an experiment on the planet that hasn't been done for a long time. That's what actually Roger Bell wrote decades ago. He was thinking of it as an interesting experiment to understand the carbon cycle. But the point is, this is really a remarkable thing that's happening to the atmosphere. Today, atmospheric CO2 is higher than any human, indeed any hominid species, has ever seen. So there's going to be all sorts of surprises. So that's really the way I think of this problem. I think of it in a nutshell, and I'm not going to talk about climate science a lot today. I want to talk a little bit about some of the impacts. But I want to say that we're performing an experiment at a planetary scale that hasn't been done for millions of years. No one knows exactly what's going to happen. Our best models, which are not perfect, but they represent our best understanding of all of the components of the climate system, tell us that there are going to be winners and losers, but that many impacts will be severe. In fact, the models do a perfectly good job of saying this is a serious problem. And we could talk in detail about all of them. I want to talk about a couple of examples for specific reasons, but I'm not going to go through all of the impacts of climate change. I'm going to assume that we've talked about that in detail. But the important point is that there are going to be surprises. But what I want to talk about today in the discussion of ethics and climate change and climate engineering is that I've been worried for a while that the communication of the state of science, both to people interested in impacts, economists, various types of social scientists, and policymakers, actually is understating our knowledge of the climate system and understating the risk dramatically. And I'll approach that in a couple of different ways. First of all, let me give you an example of how conservative scientists are. Scientists are extremely conservative. We actually are trained to think about 95% confidence intervals. And when we don't know something for sure, we don't like to give an answer. And that is very deep in the culture of science. This is from the IPCC. And by the way, when you take a bunch of conservative scientists and then you take a whole bunch of them and put them in a room and tell them to reach a consensus, you get an even more conservative answer. This over here is July, August, September sea ice average for the period by the end of the century, 2080 to 2100. That's what it was supposed to look like by the end of the century in the IPCC, in the most recent IPCC. This is very interesting because this is what it looked like in 2007. This white area is September 14th, 2007, very much like what the IPCC predicted for the end of the century. Arctic scientists who studied sea ice for decades were shocked and surprised by what happened in 2007. In 2008, just missed exceeding that because there's a number of feedbacks at play. It's extraordinary. The entire margin of Russia's ice-free, the entire Northwest Passage is completely ice-free. This is really shocking. I actually got a call from Congressman Waxman's office before he obviously took over the House Energy Committee. His chief of staff said, "What the hell are you guys doing? You know, you were telling us 2050, 2080 when the Arctic was going to be ice-free, but now they're talking, some scientists are saying 2015 is possible." I think it's still unlikely it'll be 2015, but it's possible. We don't understand the system very well. And I said, you know, this is the problem. We tend to be conservative, and what that means is when we're wrong, we tend to be wrong in the wrong direction. There is an inherent bias in what the scientific assessment of climate change is, and it's pretty systematic. And this is a nice example of that. Let me give you another example that I think is very telling as well. And this is a gravity measurement of mass loss in Greenland. And there's lots of uncertainties. Frederick Simons could talk about this in detail. But this is an estimate from a satellite observation suggesting that Greenland is losing mass at about 240 cubic kilometers of ice a year, which turns out to be about 0.5 millimeter of sea level rise globally per year. That actually isn't a big worry. It's 5 centimeters over the century. Okay? But this is what the IPCC did. This is the sea level estimate for a range B1, B2, A1b, A12. For those of you who don't know, these are different emission scenarios, and we'll talk about these in a minute. But these are different scenarios for carbon emissions over the century. And this is the estimate of, under these different scenarios, how much sea level will go up due to global warming. And it ranges from, 30 to 45 centimeters over the century. But what you see is that the biggest term in this is this red cross, which is the thermal expansion of seawater. That's just the ocean heating up and expanding. The glacial melting terms are the blue and the purple, these two. They actually cancel out. They have Antarctica growing a little bit and Greenland melting a little bit. But look at the Greenland number. It's 5 centimeters over the century. The reason for this is very simple. The state of glaciology is very poor. We actually don't have ice sheet models that reproduce ice streams that we observe in Antarctica and Greenland. The ice sheet models don't actually produce ice streams. So our understanding of the physics of how an ice sheet responds to a warmer world is so poor that nobody wants to make a guess because it would be just that, a guess. We're having a workshop at Harvard next month on this topic, and glaciologists are really tired of being asked because they really don't know. So when you put a gun to their head and say, make an assessment, they say, okay, we'll just say it stays the same. Literally, that's what happened here. But what's the probability of the Greenland ice sheet melting at exactly the same rate through the century as the Earth warms? It seems implausible. Possible, But it seems like the most conservative answer you could give, probably. It's certainly not a good risk assessment of what might happen. And I think that is the most important thing. That ultimately, we're talking about risk here, and this miscommunicates risk terribly. So, Greenland, there's 7 meters of sea level equivalent. West Antarctica, 6 meters. East Antarctica, a whole lot more. And we just don't know how long it's going to take for them to melt. It could be 1,000 years. It could be 200 years. And what's problematic about this situation is that collapse of Greenland or collapse of West Antarctica that's talked about in the literature, Mike Oppenheimer, who I think is in Europe today, unfortunately isn't here, but writes about this a lot, it's often referred to as high consequence, low probability events. And I think we have a bias here. Even in the scientific community, we think about these things as low probability when they're in fact unknown probability. We don't know what the probability of Greenland collapsing over the next century is. So we assume it's low probability, and this leads to a literature, for example, in economics on fat tails versus thin tails, things that are high consequence but out at the low probability end of the spectrum. But in fact, I think this is a terrible risk assessment exercise because, in fact, it is unknown probability. It could be high probability. And that is something that I think is often misinterpreted from the scientific assessment process. There are a number of ways that scientists miscommunicate. To me, here's something that is not low probability. This is actually high probability and potentially highest consequence. If you ask me right now, what is the biggest impact of climate change on society, I would say sea level rise is a big deal, partly because it affects a lot of rich countries. But far bigger than that is mountain snowmelt. Mountains are natural reservoirs for water. Snow falls in the winter and then melts throughout the summer. So in California, the breadbasket in the Central Valley, you have the Sierra Nevada, which essentially holds snow throughout the year and melts and contributes to the California river system. This is a model, and again, I'm not actually a big fan of some of these climate models. I think they're wildly inaccurate, and some of them are I can show you, based on the geologic record, are likely to be lower sensitivity than the real Earth. That is, they're underestimating how big the effect of CO2 on climate is. But let's just take it as an example. This model shows the advance of the timing of snow runoff, and you see that for most of the western U.S., you're talking about reds and purples. The Sierra Nevada, that's 60 to 80 days earlier. What that means is the Sierra snow melting and the rivers running dry. First of all, massive flooding in the Sacramento River Valley, which is happening already now in the spring, but imagine massive floods in the early spring. And then essentially running dry by midsummer, by the end of June. That means California agriculture is essentially unsustainable the way it is now. You can't put enough reservoirs in place to make up for the Sierra Nevada. And this is not just true in California, it's true all over the western U.S. But if you think that's a big deal, think about the great rivers of Asia. The Indus, the Ganges, you could add the Brahmaputra, the Mekong, the Yangtze, and the Yellow. And what's interesting about these rivers is that they're all sourced from a region in the Himalayas and Tibetan Plateau. And there are a variety of estimates, and I think there are a lot of good people who are beginning to work on this now. I don't think the numbers are very certain yet. But the estimates that I've seen suggest that in the last 40 years, something like 25% of the ice and snow mass has been lost. And I don't think anybody has any idea right now how much more of it will go over the century, but there are people making rather catastrophic predictions. The fate of mountain snowmelt in general is not good in a warmer world. That we can say with confidence. The Indus, for example, I don't know how many people know about the politics of water in the Indus. Maybe Mike knows about it. But it's complicated. The Indians and the Pakistanis have a treaty. But it was, unfortunately, for the Pakistanis, based on total volume, like the Colorado. It was based on total volume, not percentage of flow. So there's going to come a time when the Indians are going to take their water and there's going to be no water left for Pakistan. You want to look at a political disaster in the making. Think about water stress added to what many would say is a failed state already in Pakistan. And you're talking about a very difficult situation. So I think things are going to get much worse. And I think in general, the climate science community, in terms of doing a risk assessment, when scientists are asked to assess the science, we tell people what we're sure of. But that does a terrible job of assessing the risk of serious consequences of climate change. So, one, scientists tend to be conservative. And that means that scientific assessments tend to ignore or de-emphasize highly uncertain issues. And such issues are then often treated by economists and policymakers as high-consequence, low-probability events, when in fact they may actually be medium or high-probability events. We just don't know. And that may sound like a subtle distinction, but it turns out it really matters, I think, in thinking about the state of emergency that we're actually in. In addition, communication of probability by the IPCC using language of risk, and this is something that is very specific to the IPCC. My colleague at Stanford, Steve Schneider, proposed that in order to save a lot of time and arguments between people in the IPCC, I don't know how many people here participated in that process, but instead of using language of probability, 1% chance, 10% chance, 50% chance, that they use words like very likely, medium likelihood, unlikely, very unlikely, to correspond to specific probability ranges. And that's what they did. And it saved a lot of arguments about exactly what number the probability should be. It sounded like a great idea at the time. The problem is that that actually miscommunicates the concern we should have for such events, because these words are actually used for risk, not for commonly. We use them for risk, not for probability. Tony Patt and I did an experiment a few years ago where we actually asked people, we said, imagine you're a weather forecaster in Boston, and somebody tells you that the National Weather Service says there's a 10% chance of rain tomorrow. What word do you use to describe that risk and communicate it? And then we asked another group the exact same question, but instead of rain, we said there's a Class 5 hurricane heading up the coast, and there's a 10% chance that it'll make landfall in Boston. What word do you use to describe that to your audience? And sure enough, people used the higher likelihood words for the higher consequence events. That is, they were using the words to communicate risk, not probability. What that means, though, is that when they hear from the IPCC that the collapse of the Greenland ice sheet is very unlikely, they mean not what the IPCC was saying, which is less than 10%. They thought, oh, I don't have to worry about it, because 10% chance of the Greenland ice sheet collapsing, I mean, what's the probability of your house burning down? It's like, what, 1 in 100,000? You know, Greenland ice sheet collapsing, right? Yes, technically it's defined in the IPCC, but it's miscommunicated to the public. I think that, again, was an example of a serious problem. Okay, a few other components of the climate system that are worthy of understanding to think about the ethical components of climate engineering, where I'm heading for this. And this has to do with scenarios. These are the IPCC scenarios that I talked to you about. This is carbon emissions. Sorry, it's cut off. It's in billions of tons of carbon per year. So these were the different trajectories. Today we're actually at like 8.5. We're much higher than any of these scenarios, unfortunately. But the high ones are called the business as usual scenarios. The green one is the sort of, some people jokingly refer to it as the kumbaya scenario, where everybody holds hands and reduces emissions together. I'm a little more optimistic than that, but that's the sort of spectrum. And again, these aren't predictions of the future. It's very important to understand. These aren't predictions. They are scenarios to help think through different possibilities for possible futures of the world. Okay? And they're very useful exercises in that way. And they then lead through a carbon cycle model to CO2 concentrations in the atmosphere. But one of the consequences of this is that the atmosphere, CO2 has a long residence time in the surface ocean and atmosphere. And so as a result, the green scenario, you're still getting above 500 ppm. The business as usual scenarios, you're heading towards 800 to 1,000 parts per million. Okay, and that's just part of the built-in chemistry and physics of the ocean-atmosphere system. This, by the way, doesn't include any feedback effects like drying out of the Amazon basin or melting of the tundra, producing a lot of carbon from soils into the atmosphere. None of those feedbacks are in these sort of calculations. Those are all additional. Again, measures where we tend to be more conservative because we don't actually include them in our discussions. So what is the solution? How do we keep CO2 below a dangerous level? The problem is we can't tell you what level is dangerous. There is no certainty around that. And remember, there's great momentum in the climate system because of the long lifetime of CO2 in the atmosphere and the long lifetime of energy capital investments. So the way you can think about it is, this is what John Holdren used to say during the Clinton administration, we're not driving a sports car, we're driving a supertanker. Doesn't handle very well. It takes a long time to slow down, which means you can't hit a catastrophe and turn around. If you see a shoal up ahead, you've got to throw yourself in reverse long before you actually hit it if you're going to actually avoid the worst consequences. So this is unfortunately one of the worst aspects of the climate problem because it means we can't wait and see. Okay. So a few comments that I just want to say. These are basically my opinions. Stabilizing greenhouse gas levels, either by changing behavior or by changing technology or both, is certainly possible. In fact, I'm spending about a third to half of my research time now working on technological solutions to the carbon problem. But I got to say, we're heading in the wrong direction fast. And the reality is, although I hope we do a lot more, even if the U.S. could achieve massive reductions in emissions, the whole world has to too. And this is really not looking like it's going to happen in time. I mean, I think back to a conversation, I was mentioning this earlier in the day, I had with my friend Jeff Sachs, who thinks about world poverty. And I said to Jeff, do you really think that the chances of solving the problem of the poorest of the poor, as Jeff talks about it, you think the probability of that's better than 1 in 1,000? And he said, I'll take those odds. He's not naive. He understands that he's trying to work on a really difficult problem. He's just trying to solve it. I kind of feel like this is the same way, and I think if we're honest with ourselves, we have to realize that, God, I hope we can fix this problem, but it's not looking very good. I have in an undergraduate class, I have students make a plan, what Obama and Clinton both promised, an 80% reduction by 2050 in the U.S. An 80% reduction of emissions. If you actually try the exercise of figuring out how to supply energy for the U.S. economy and reduce carbon emissions by 80%, it is really difficult to do it just with a magic wand, doing it, forget trying to do it in policy and economic space, just in engineering the problem. It's really hard. And we have 40 years to do it. It's not a lot of time. So again, I don't want to get too depressing, except that and I'm still again optimistic, but I think we have to at some point step back and be realistic about where we are, which direction we're heading. By the way, it's still accelerating in the wrong direction. We haven't thrown it in reverse. Obama is willing to spend $15 billion a year for 10 years on clean energy. That's an order of magnitude at least too small. It's better than what was going on before, but we're still not. We're not heading in the right direction. So I think it remains possible and even likely, if we're really honest with ourselves, that global efforts will fall far short of what's required to prevent massive suffering, both by human societies and by the natural world. In fact, some people believe that massive suffering by the natural world is already occurring. There's a history of trying to model this discussion. This is old work from the Patel Group and the Pacific Northwest National Lab Group. And Steve and Rob together did this beautiful simplification of this into these stabilization triangles, the wedges, which really made everybody understand what the gist of the problem was and made the point that we can do a lot to start now towards a stabilization scenario. But there's some things that people forget about this. And Rob and Steve understood this, but people forget. First of all, this doesn't get you to a solution. This just gets you to a stabilization at around 500 or 550 parts per million. Moreover, after 2050, you need a lot more because you're actually going in this direction. So you need to actually reduce your emissions while demand is likely to still rise, and that means you have an even bigger problem. Hopefully, new technology will just solve the problem, but I'm not sure I want to bet the world on it. I'm going to try to skip this next one. This is a scenario I just did with my class, just a simple version for the century, similar to the wedges, but just giving you a scale of the problem. just showing you the kind of growth rates we're talking about. And this is the problem of exponential growth over the century, which is the next thing I want to briefly talk about. That's what 550 ppm looks like. But this just illustrates the challenge of what the latter half of the century brings if demand is growing. And by the way, 1.5% is on the low end of many growth scenarios. The wedges went to what, 2054, was it?
Yes.
That's here, right? But there's a lot of fossil fuel that potentially could be burned after that. And the problem gets much worse. By the way, one of the things that Rob and Steve understood very clearly and explained to people was that there's really three ways to think about this problem. All of the wedges can be grouped into three categories. You can use less energy, either by better efficiency or conservation. You can add non-carbon energy by renewables or nuclear, or you can use fossil fuels and capture the carbon and store it underground. A quick analysis of the problem says you need all three, and we don't yet know how much of each, but all three are going to probably be very big. I think Rob would probably agree with that. Let's go back to these scenarios. These different scenarios that are used by the IPCC, there's something that always has bothered me about this. When you actually look at detail at the scenarios and where they come from, you discover something very interesting. This is a simple way to think about the construction of this. It really goes back to work in the early 70s by Paul Ehrlich and John Holdren, what many people call IPAT, which is impact equals population times affluence by technology. This is a trivial argument in some ways. It's an identity. It's true by definition. It's just saying the carbon emissions equals the population times the GDP per person times the emissions per GDP. Right? It's true by definition. But it's a nice way of thinking about what the driving forces are. And this is sort of the framework that was used in the IPCC in thinking about this problem. The driving force turns out to be, the big one, is GDP. Many people ask about population. Most of the population scenarios we'll see in a second are pretty consistent. They basically peak world population around 9 billion by the middle of the century. Some of them go to 11. But those are small increases. This is the GDP growth rate in the IPCC, the range from the literature that they used. And you see this partially reflects the economists' optimism about how the economies will always grow. The last 6 months notwithstanding. And you see the growth rates range from around 1% up to 3-ish%. But over the century, those are really big growth rates. Let me show you what this means. This is from the IPCC scenarios. So here's population. In 1990, 5.3 billion. And in the different scenarios, by the middle of the century, 8.7, 8.7, 11.3, 8.7, 9.3. They're all pretty much the same. And again, it's a 50% increase. Look at world GDP, $21 trillion in 1990. The different scenarios, the lowest growth scenario, which is this one, has it increasing more than tenfold. The highest one, I guess it's this one, has a 25-fold increase in GDP. That's extraordinary. This is a per capita income ratio. It's the developed countries to the developing countries. Essentially, it's Annex 1 to non-Annex 1. Okay, and you see that ratio, essentially rich countries to poor countries, is 16 in 1990. By the end of the century, these scenarios have the ratio of rich to poor being only 1.6. The most unequal world, the most unfair distribution by the end of the century, still has that ratio improving by a factor of 4. Coupled with a 25-fold 10 to 25-fold increase in GDP, what this means is the average person in what is now the developing world is richer than we are here today. Now, I don't know how probable many of you think this is, but to me, what's interesting is that there are scenarios that are excluded from this discussion. This is partly a bias in the UN. It's partly a bias by economists, and it's partly a bias by the UN process where saying that people are going to stay poor is really not acceptable. The irony is that you can't achieve these kind of growth rates in GDP unless there's huge economic growth in places that are quite poor now, but that are beginning to grow rapidly, like India, South Asia. Eventually Africa too, but I don't know how we're going to solve the Africa problem. But essentially these growth rates require that huge, phenomenal, sustained growth rates in India have to occur over this century. Well, I go back to the water problem and say, I just don't see, if you actually grow this fast, and that therefore means emissions go up high, I actually think it's impossible to sustain the growth based on the climate impacts. There's sort of a good news here. The good news is that the high business as usual scenarios, I think, are probably impossible. They can never be achieved. The reason, to put it another way, is that we take demographic models, economic models, energy technology models, we put them into an emissions scenario, which I just showed you. We put those into a carbon cycle model and produce a radiative forcing scenario, which we feed into a climate model and come up with a climate scenario, which then economists take and put into an economic model, whether it's Nordhaus or Jorgensen or whoever, and ends up with a climate change impacts discussion, economic impacts. The problem with this is that there's this big negative feedback. And that loop is rarely connected. Some groups have tried to connect it, but I don't think they've actually connected it well enough. Because in fact, if the growth rates are as fast as they say, there is no way you can sustain the kind of high growth rates in the developing world where impacts like water are going to be severe. That's good news. It means we're probably not going to see 800 ppm. That's just not possible. But 500 ppm could still be a disaster. We don't know. It is quite possible that the best we can do, maybe 500, maybe 550, is still really, really bad. So that's where climate engineering came from. We had a workshop at Harvard 2 years ago, a year and a half ago. David Keith and I organized it with a number of other people. And it was an interesting discussion. It was intended to be, it provoked a huge amount of controversy. People were angry that we were even having the workshop. And many people came to the workshop, but on the first day privately told me that they thought they shouldn't be here because it was immoral to discuss it. And this is where Dale's work comes in. Now, many people talk about geoengineering, and that's the way people refer to this commonly. I like to call it climate engineering because geoengineering has become a catch-all for everything on this diagram, which includes pumping CO2 into the ocean, which is against the London Convention, iron fertilization of the sea, which I don't think works for completely independent reasons, pumping CO2 into rocks, which I actually don't think should be called geoengineering. That's just carbon sequestration, but that's a separate discussion. Growing trees and genetically engineering crops, et cetera. Climate engineering I think of as something else, and it's based on the time scale of the response and the ability. So any of these things essentially operate on the carbon cycle, and they might have the capacity to take off 1 billion tons of carbon a year off the table out of current emissions of 8.5 billion tons a year from fossil fuel burning. But these other things, aerosols in the stratosphere, giant reflectors in orbit, cloud seeding, those are things that can actually have an immediate effect on the climate. They're essentially a sunshade that is reflecting sunlight back to space and cooling the Earth, trying to compensate for the extra long wave absorption of the greenhouse gases. Of these, the giant reflectors in orbit turn out to be obscenely expensive, and we don't really have the rockets to put them in place, so you don't have to worry about those. But the aerosols in the stratosphere turn out to be incredibly cheap. So amazingly cheap that, the National Academy study in '92 basically said, you can put them in 16-inch naval guns and shells and shoot them up vertically, and it would do just fine. Cost would be less than $1 billion a year, which, compared with rehauling the energy system of the world, is really cheap. Right? You can essentially think of that as free. The problem is we don't know very much about this, and it's very scary to people. And people find it, in some ways, unethical to even discuss it. So these are the questions we asked at this workshop, and we discussed for 2 days. The discussion was off the record, so I can't tell you what we discussed, but it was a very interesting set of issues. One, how do you actually do it? what does it actually do to the climate system? And one of the goals of this workshop was to bring together some of the best climate dynamicists in the world to begin to think about this, because most of the people who had worked on this were actually advocates for it. I should note that the person who really was the most famous person who really started talking about this idea was Edward Teller. And it was his protege who's really been the most prominent in thinking about this. And he's done this publicly, so I can tell you that he did this publicly, but also at our workshop. He got up and literally said, we now have the technology to produce a Mediterranean climate for everyone, with a straight face. I couldn't believe it. Part of the reason I had the workshop was that I didn't want him to dominate the discussion of whether we should be doing this to the climate system. I wanted really good climate scientists to be in the room and think about the problem. Think about what might go wrong in the climate system. What might be a problem? Does it postpone the need to reduce emissions? And will it postpone the reduction of CO2 emissions? Who controls it? Remember, any one of about 50 countries could afford to do this and has the technology to do this. It's not difficult. When should we start, if at all? And what do we need to know before we start? These are the sort of questions that we were grappling with. Now, ethics in climate change. One of the questions I want to ask here today, and hoping Dale will help us answer it, is why is there such a strong ethical concern over climate engineering, but relatively little concern about the ethical issues and biases related to climate change itself? Now, I know Dale has written about climate change ethics as well, but in general, when you talk about climate change, nobody asks you about the ethics of it. When you talk about climate engineering, 90% of the questions are about the ethics of it. Just as empirical observation as somebody who speaks about this sometimes. Interesting. What are the ethical biases we bring to the discussion of climate change and climate engineering? And one of the influences for me has been the work on bounded ethicality by Max Bazerman, who's a professor at the business school, behavioral economist, colleague of Danny Kahneman here at Princeton. This is Dale's paper, and I really want to applaud Dale for writing this paper so early. And I want to play a little bit of use this as a straw man. I hope Dale won't mind. I got to emphasize to you, he did this, 14 years ago, before I was even thinking about climate change in the modern. So he was way ahead of his time in thinking about this, and I'm sure he would revise it. Let's accept this as an early dated version of it. But I want to bring up some of the points he made as discussion points. You might say, if it were Shakespeare, come to praise Dale, not to bury him. But we might end up revisiting that. Jamieson proposes 4 conditions that must be satisfied for an intentional climate change project to be morally permissible. 1, the project is technically feasible. That's not a big issue because, obviously, we're not going to really be discussing it much if it's not technically feasible. 2, its consequence can be predicted reliably. 3, it would produce states that are socioeconomically preferable to the alternatives. And 4, implementing the project would not seriously and systematically violate any important, well-founded ethical principles or considerations. 1 and 3 seem pretty obvious to me. And I would not just say socioeconomically, but let's use a broader adjective than socioeconomically. Right? Obviously, you're not going to do it if you think the outcome is going to be worse. But 2 and 4, I actually think are pretty high bars, maybe impossible bars. And I think we should rediscuss those, rethink those. Can the consequences be predicted reliably? This is from the paper. It might be claimed that this condition rules out too much. Reliable prediction is hard to come by. I agree. But reliable prediction has been one of the central goals of science since at least the 17th century, as well as one of the stated goals of the U.S. Global Change Research Program. If technological interventions have the potential to bring about quite profound negative effects, it is not too much to ask if their advocates know what they are doing, and in this case, there's little evidence that they do. I agree with Dale. There is little evidence that people like this protege of Edward Teller actually knows what they're doing in thinking about the climate system. And certainly we need to do a lot more work thinking about what those impacts really are likely to be. But the goal of actually predicting this consequence reliably, I would say, is out of bounds. And the reason is we can't do that for the climate system. And in fact, the same sorts of unknown feedbacks and mysterious feedbacks that are going to surprise us, some of those same feedbacks are going to apply when you're monkeying with the radiative balance by putting aerosols in the atmosphere, in the stratosphere. And so the choice, remember, we're not making a choice between doing this and nothing happening, instead everything staying the same. We're making a choice between letting the Earth warm up because of greenhouse gases or trying to compensate for it by reflecting sunlight. And the uncertainties, because of feedbacks in the climate system, are there either way. The uncertainties you're not going to get rid of. We're never going to be able to predict what's going to happen. We can maybe assure ourselves that the possibility of really negative consequences is low, but we're never going to be certain. That's just never going to happen. So what about the other one? Implementing the project would not seriously and systematically violate any important, well-founded ethical principles or considerations. This is something that I'm sure he'll talk about, but I want to mention a few biases that I see in this discussion. And in many discussions that people come to me with this, surrounding these whole issues. One, what I would call sort of a pastoral bias. What I mean by that is sort of a nostalgia for simplicity, a la Thoreau. There's a wilderness bias, desire for nature untouched by humans. A nice example is the U.S. environmental movement versus the EU environmental movement. There is no wilderness in Europe, so the environmental groups care about clean air and water for people. In the U.S., the heart of the environmental movement, not all of it now, but the heart of it is still in preserving wilderness in the West. That's since the time of Teddy Roosevelt. That's sort of been the passion of the U.S. environmental movement. I think there's an anti-technology bias as well. We don't like technological solutions. Basically, we should solve the climate change problem by changing behavior, reducing consumption, slowing economic growth. The French, 5 years ago, when I gave a talk on not climate engineering, but just on carbon sequestration, they attacked me afterwards, including some of our dear friends who work on ice cores in France. Were very upset by suggesting that you needed this. They basically said, come on, if you Americans just lived a little more like the French, you'd be fine. We'd all be fine. Well, they're wrong. You Americans, you could cut out the 20% of world emissions that the Americans are responsible for, and you'd still have a huge problem. Just living like the French is not enough. But it showed this bias that essentially we don't like technological solutions. I think Dale suffered from this a little bit too. Many of our environmental problems, he said, flow from attempts to manipulate nature in order to make it conform to our desires rather than forming our desires in response to nature. We have improved nature in many ways, bringing water to places where people want to live, exterminating animals who prey on those we raise for food, dredging harbors and filling wetlands so towns and cities can be developed. Although it is not possible or desirable for humans always to let nature take its course, there's a growing sense that modern societies have erred on the side of excessive intervention. We've become arrogant and intrusive in attempting to manage all elements of nature. The growing interest in, admittedly ill-defined, concepts such as sustainable development reflects in part this growing sense that things have gone too far. I think many share that sentiment. The problem is, in the climate system, I believe we're actually really up against it. We don't have the luxury of this. So we would say then, since human behavior is revisable, modifiable, and affected by learning, behavior change is the best response strategy for addressing many environmental problems. In my view, it is also the most ethically responsible strategy in many cases, since it demands that solutions to problems be located in their source, humans, their behavior, and their institutions. I think this is a wonderful sentiment, but unfortunately naive when you actually look at the way the world is heading. We're talking about a system of mass action that is heading rapidly in the wrong direction. It's the ultimate free rider problem, where nobody has a lot of incentive to lead in reducing emissions. He followed by saying this: we can think of large-scale human manipulations of the environment as popping the rivets, this is following a Paul Ehrlich quote, in the attitudes and dispositions that are required in order to live peaceably with nature. Attempting to change global climate would be a very grand gesture. I've given various reasons for supposing that such an attempt would be risky and probably ethically wrong. But even if the ICC were successful, it would have the bad effect of reinforcing human arrogance and the view that proper human relationship to nature is one of domination. Although it is difficult to assess precisely, in the long run this attitude may be more destructive of both humans and the rest of nature than global warming itself. Well, I guess that depends on how serious a problem we think global warming is. I actually believe that global warming may be such a serious problem, that it's such an emergency, and I think people probably didn't think that in 95, so we give Dale a break on that. But that today, I think this is entirely wrong. In fact, the situation may be so bad that I think of climate engineering when I give public talks about it, not as a Band-Aid or a techno fix, but a tourniquet. You put a tourniquet on to keep from bleeding to death when you are worried about dying from loss of blood, but you still go to the emergency room, right? It's not a cure, but you still may need it. And I think that's the way I think about it in terms of climate engineering. This is the work on bounded ethicality by Max Bazerman, and I want to end briefly by just talking through some of these observations. I think the psychological experiments and behavioral psychology, the behavioral economics field has a lot to teach us in this area. What Max was interested in is why we don't see or act on unethical behavior of others, and why sometimes we do things that are unethical, but we're not aware of them. We actually think of them as ethical acts. Ethics usually refers to things that we do out of selfishness or self-interest that hurt others. And in this case, this actually might happen, and yet we're conscious of the decisions, but we actually don't think of them as unethical acts. Bounded ethicality refers to the systematic and predictable ways in which humans act unethically beyond their own awareness. There's boundedness in your own ethicality and also in noticing the ethicality of others. So in your own ethicality, there's all sorts of examples based on implicit attitudes and on discounting the future. I'm not going to go through all of these, but there's a lot of interesting material here that I encourage people to look at. I just want to mention a couple of these. There's boundedness and noticing the ethicality of others. And there's all sorts of things: outcome bias, slippery slope, indirect bias. I want to mention a couple of these ones. Think of the following example. A pharmaceutical researcher defines a clear protocol for determining whether or not to include clinical patients as data points in a study. He's running short of time to collect sufficient data points for his study with an important budgetary cycle within his firm. As the deadline approaches, he notices that 4 subjects were withdrawn from the analysis due to technicalities. He believes that the data is in fact appropriate to use, and when he adds those data points, the result moved from not quite statistically significant to significant. He adds these data points, and soon the drug goes to market. The drug is later withdrawn from the market after it kills 6 patients and injures hundreds of others. That's scenario 1. Scenario 2 is almost the same, except instead of noticing that 4 points were withdrawn from a technicality and adding them back in, the researcher now makes up 4 data points to add significance. He makes them up. The drug turns out to be profitable. It's effective, and years later shows no significant side effects. And people are asked to rate the ethicality of these different things. It turns out they're highly biased by the outcome. This is considered highly unethical. Somebody who just literally added 4 data points back into a study, real data points, they were eliminated based on technicality. Whereas this person made up data points, but because of the outcome, didn't get penalized. Interesting. It's a psychological bias we bring to this that's significant. I think this is actually the fear when we actually think about the unintended consequences of climate engineering. We're heavily biased by the possibility of these unintended consequences. Ironically, the intention of climate engineering is to fix the problem. The intention of adding greenhouse gases to the atmosphere is more questionable. Some people would say climate change is unintentional, climate engineering is intentional. We'll talk about that in a minute as well. This is the classic example, the trolley dilemma. Many people are familiar with this, where you have a trolley, and on one side there's a bunch of people, and on the other side there's one person, and you're at a switch. The trolley right now is going to head for the whole bunch of people. Do you throw the switch and have it hit just one person, or does it kill the 10 people or whatever? And I've seen versions of these done where instead of the behavioral economists try to measure, like they put your mother over here. And they say, okay, how valuable is your mother relative to one person, 10 people, 50 people, 100 people? You can go into all sorts of fun games like that, okay? If you think that's fun. Another version of this, though, that's very interesting. So most people, it turns out, that you'd throw the switch. You could see that it's probably better to kill one person instead of 10 people, because you have to choose one way or another. Here's a very similar experiment. It's a bridge. You're standing on the bridge with another person, and you know there's a trolley coming, and you can see 10 people down the road, down the path, and there's somebody next to you, and if you push them off the bridge, they'll fall on the track and stop the trolley. People don't do it. The difference between these two, you could argue, is pretty subtle. One person dying versus 10. And yet, somehow, the act of pushing them off the bridge versus throwing a switch is very different to people. Interesting. This is, I think, one of the biases that we come with the climate engineering problem. Somehow, the intentionality is perceived as much more powerful for climate engineering. Ironically, I actually think the climate change itself is more intentional than we acknowledge. We talk about it as unintentional. And yet, if you smoke cigarettes for a few years and then somebody shows you very good data that cigarette smoking causes lung cancer and you keep smoking for 30 years, you begin to have some accountability and responsibility for that action. I actually think talking about climate change as an unintentional act is really no longer possible in 2009. So the idea that somehow climate engineering is intentional and climate change is unintentional, I actually would question that. And yet, that's the way we all think about the problem. Here's another nice example of this sort of bounded ethicality. A major pharmaceutical company had a cancer drug that was minimally profitable. The fixed costs were high and the market was limited, but the patients who used the drug really needed it. The pharmaceutical was making the drug for $2.50 a pill and was selling it for $3 a pill. It was just not cutting it. So in one case, the major pharmaceutical firm raised the price of the drug from $3 a pill to $9 a pill, ensuring high profits that they're used to on their drugs. Of course, that really hurts the patients who really need it because there are no alternatives. But it's a small number, so it doesn't matter that much. The other option is for that same company, big pharmaceutical, they're worried about this outcome because they're going to get a lot of bad publicity for fleecing these poor patients who need the drug. So in this case, they sell the rights to a small company who has no public persona, who has no reputation, and they actually raise it fivefold to $15 a pill. The outcome being, of course, that the people are even worse off, the patients who need the drug. It turns out that this isn't a hypothetical. This actually happened. So Merck did this. It turns out that there's often this idea that an indirect, somebody else's bad deed, even if it's foreseeable and predictable, is somehow not as bad as you doing something bad. Many people will, when surveyed, would say that A was worse than B. And many firms perceive that A is worse than B, and therefore they're quite happy to do B and let somebody else make the ethical decision. Okay. There are lots of things, and I'm going to stop right now. But are we hesitant to think of climate engineering as a valid emergency response to climate change because we don't understand how bad the situation is? Are we just not aware or fooling ourselves that we're really in as dire straits as we are? That we focus too much on short time scales? Or we worry about our own responsibility for what might go wrong as opposed to really being scared to the point where we think it's an emergency situation? And to me, the emergency nature of this is important in thinking about the ethics of this. We certainly allow ourselves more ethical latitude when we actually are in an emergency situation. Let me make no mistake. I'm not in love with climate engineering. Climate engineering, as I like to say, is the worst possible idea. It's the most arrogant, hubristic way of thinking about the relationship of humans to the natural world. And yet it may be better than the alternative. And that's what we have to get our heads around. So I'll stop there and let Dale think about this a little bit. Thanks.
Thanks. Can we do something about the lights? Because I'm going to do the old-fashioned thing, just speaking from some notes, which it would be nice to see.
Dale, why don't you take this?
Yeah, it'd be nice to get the screen up as well, because I might use the blackboard in that terrible, boring, philosophical, professorial way.
How about shut down?
Yeah. Okay. So first of all, do I have to use the camera?
We won't hear you.
Okay, thanks.
There's nothing
All right. No, that's not, I see. So, okay, I'll just. I've never been accused of not being able to be heard. I think just the sheer force of my voice is usually enough to get it onto the tape. I want to thank Dan for a really stimulating talk. There's an enormous amount to talk about in his comments, and I'll try to avoid the obvious temptation to be long and disorganized. It would be nice to be short and organized, but we may have to settle for one of the two, given how much material there is on the table. So the first thing I want to do is to begin by underlining some of the points that Dan made and agreeing with some of what he said. One of the things that you can usually count on is when you get natural scientists and philosophers in the same room, we can usually agree that the common enemy are the economists. And nowhere, I think, is that more true than in the climate change debate. And in fact, it's dangerous because to a great extent, the way the issue is now being framed is the scientific case is now closed in some way, so let's turn things over to the economists for the solutions. And in fact, economists do generally, systematically, underestimate the possibility of abrupt or catastrophic climate change. The normal practices of discounting that are endemic to standard economics also tends to, in effect, assume away downstream consequences of exactly the sort that we ought to be most concerned with in the case of climate change. And as anybody who has been invested in the stock market knows, economists are very bad at predicting turning points in particular. And there's not much reason to think they'd be any better at predicting turning points in natural systems than they are in financial systems, which is, after all, supposed to be something they know something about. I also want to agree with Dan about the inadequate way that we tend to think about the impacts of climate change generally. He put a slide on the board that long ago I talked about as the linear model of thinking about impacts, where we essentially start with basic science and we go all the way down to society, as if it's just this stepwise progression. And in addition to the problem of cascading error, there's also a problem not just with the feedback from the bottom, right, from what's happening in society, but actually every step along the way has feedbacks with every other step along the way. But yet somehow we still seem to be trapped into this completely inadequate model. The third thing I want to agree about is the terrible language that we've inflicted on the world when it comes to talking about climate change. I mean, nobody understands really what we mean when we talk about mitigation in the first place, much less geoengineering. What people mean by mitigation when they're talking about regular pollution problems is quite different from the meaning of that term in the climate change literature. But I'm going to follow. But since this isn't a session devoted to the rectification of names, I'm going to talk about geoengineering in the recognition that it is an inadequate term. Then finally, I also want to agree with Dan that the climate ethics discussion has been marginalized to much of the climate debate. This, in part, is due to the fact that not a lot has been written. It's also, in part, due to the fact that a lot of people who should be paying attention to ethical issues simply haven't been paying attention to those issues. And to some extent, I hope that will be rectified because in the fall, a new collection of papers called Climate Ethics will be published by Oxford University Press that does attempt to collect a lot of the work that's been done on this topic over the last 10 or 15 years. Okay, so now we start the stuff that's perhaps a bit more fun. The first thing I want to say is that one person's bias is another person's principle. And I think that tends to come out very strongly in Dan's discussion of the French. I mean, somehow in North America, we always do tend to see the French as being, sort of trapped by a particularly parochial way of seeing the world, whereas we tend to have the kind of modernist, rational way of looking at things. So I'm always struck by the way we use this term, bias. I mean, bias is sort of a way of often of referring to a principle with which we disagree. And I want to spend, I think I want to spend a little time talking about intentionality in particular. But before that, I just want to make the obvious point, which I think is often overlooked in some of this literature, that almost none of us, not even really pretty hardcore utilitarians, think that it's only the numbers that count when it comes to moral decision making. I mean, if we thought it was only the numbers that mattered, then we probably wouldn't object to the idea that when you check into a hospital, for example, for some routine operation, that if, in fact, more lives could be saved by redistributing your organs, right, to people who need them in the hospital, then why would we object if it's only the numbers that count? After all, it's just a bias that makes us see that life-saving in this way is in some way morally inferior to life-saving in other ways. Okay? So I think the first thing we have to recognize is that while the numbers are very important in morality, they aren't all there is to morality. And so it's not enough, to simply talk about everything else as a bias. We have to get in there and do some of the hard work. So I want to say a little about the intentionality issue, because that is one, I think, that comes up quite often in the climate change debate. And I want to agree with Dan that the climate change that humans have caused is not an unintentional climate change, but I would say it is an inadvertent climate change, meaning that the end of changing the climate has not been the intended end, although the actions that have brought it about are intentional actions. And I think it's important to recognize at the outset that many people, indeed I would say even scientists, when they're not thinking about geoengineering, think that intentionality matters to a whole range of issues. So just think about some examples. So we think about intentional deception as being lying, and we distinguish that from inadvertent deception, which you might think of as leaving a false impression. We distinguish intentionally running over a pedestrian, which we call murder, from inadvertently running over a pedestrian, which we call an accident. We distinguish intentionally killing civilians in wartime, which we think of as a war crime, from inadvertently killing them, which we're told is regrettable collateral damage. Now, in the trolley case, the fact is that almost everyone feels the pull of the intuition, even utilitarians feel the pull of the intuition, that while it's permissible, maybe even obligatory, to flip the switch that moves the train from the track where it's going to kill the 5 to the 1, almost nobody sees this as the intuitions being identical in the case of the fat man, right? I mean, the switch comes about in different ways. Some people think it's obligatory to flip the switch so that it kills the 1 instead of the 5. Nobody would think it's obligatory to grab the fat man and throw him over the bridge, right? I mean, at best, some people might think it's permissible, okay? So even in the fat man case, I think there are very, very deep intuitions we have. Now, maybe they're wrong, but they can't simply be dismissed as being a bias. Considerations of intentionality are very, very deep in our moral consciousness. So the point is this: they're not ad hoc intuitions that some Luddites are bringing to bear on geoengineering. They're very deep aspects of our moral consciousness and have to be addressed in that way. Intentionality often changes the very nature of an act itself, from an accident to murder, for example. And in many cases, as I've suggested, it changes the moral valence of the act from being permissible, obligatory, wrong, or whatever. Okay, so what I've been trying to say about intentionality then is, just to briefly summarize this point, is that the role of intentionality is deeply embedded in our moral consciousness. It is a matter of intense philosophical research. Roughly, the sharks and jets on intentionality are deontologists and utilitarians. By and large, utilitarians think intentionality is less important. That's the gang I'm more inclined to side with. So in that sense, I'm sort of in Dan's spirit. But again, almost no one is going to go all the way and say it never matters. Okay. Now, I think what we think about geoengineering in the end will in part be a reflection of what we think about deeper questions about ethics. But it's not as though we're going to revise our moral philosophy so that we can come to think about geoengineering in a new way. I mean, we're not, in that sense, our ethical reflection will lead us in our moral opinions of geoengineering rather than the other way around. And anyway, even if intentionality is just a bias and without any moral relevance, the most it would do would be to remove one argument that might be used against geoengineering. And it would still be the case that we would need some positive argument for geoengineering. Okay, I want to very quickly then go on to just, in a way, list some other ethical concerns about geoengineering that have been raised, just to kind of get them on the table for discussion, because otherwise there's a tendency to foreshorten the discussion, I think. So let me just give you a list of concerns, a relatively short list. First, there are questions about what principles govern the means that we might use to set the global thermostat. Okay, so I'm going to talk about geoengineering as setting the global thermostat, because I'm going to just assume that we know how to do that, which is itself obviously controversial, right? But Dan showed this slide of a lot of different geoengineering techniques, and all of those have different consequences besides the way that they set the temperature. In many cases, they have different consequences in terms of the distribution of weather. And remember, weather is what people live with and what affects their lives, not an abstraction that we call climate. But in other cases, they also have different consequences for what else is going on in the Earth system. So we would need some idea of, cheaper is better, everything else being equal, but we need some principles for how to systematically think about how we should make choices from the menu of possible geoengineering options. Secondly, there's a question about what principles govern where to set the global thermostat. Now, again, a lot of people think there's some bias in wanting to distinguish intentional action from inadvertent action, but isn't there a bias in wanting to turn back the thermostat to the pre-industrial baseline? What's special about the pre-industrial baseline? Maybe the thermostat would be better set, a little cooler, a little warmer. But why just there? Is that some pre-industrial status quo bias that's driving us there? Now, I ask this question just because we need some way of answering that question. We need some principle. Maybe the optimum temperature, in some sense, is precisely a 0.5 degree centigrade warmer. Well, what does optimum mean there? How do we even begin to think about that question? Especially since, again, all of these turnings of the global thermostat all affect real people in very, very different ways in terms of regional impacts, which is where climate is felt. Thirdly, and I think in some ways the most important question, is, and I think this is one, sadly, that really doesn't get discussed, who has the moral authority to set the global thermostat? Now, we have some conception of who gets to send troops to Bosnia. Now, countries may violate this and so on and so forth, but we have some international norms about that. We know what it means to legitimate this kind of action. What are the legitimating institutions for controlling the global thermostat, right? What should they be? Do we let anybody who's big enough and powerful enough and a big enough hand, tall enough to reach up and turn the global thermostat? Or what should our international norms be? How do we even begin to think about that? Then finally in this area, I want to talk a little about these attitudinal concerns, which are reflected in that early paper, and I think are still worth thinking about, and they're still on the table. And I just want to mention two of them. And in part it's because these attitudinal concerns are what lie behind the sympathy for something like precautionary approaches that many people feel. In fact, maybe even Dan, when it comes to other kinds of environmental problems. And so one concern has to do simply with exaggerating expertise. One thing we know from social psychology is that experts exaggerate their expertise. And in fact, experts exaggerate their expertise more than amateurs exaggerate their ability to solve problems. So there's actually good empirical reason for when somebody says, I'm from the government, or I'm from Harvard, and I'm here to help you, right? There's good empirical reason for why we should be skeptical in these cases. And generally, the grander the project to improve our lives, the more reasonable it is to be skeptical. Now, that doesn't trump everything else, right? It's just a concern about expertise-driven decision-making. Especially since, again, as Dan said, there are going to be surprises. Just as we know the climate system is going to produce surprises, so we know any attempt to set the global thermostat is going to produce surprises, no matter how well we think we understand it. Okay, I want to very quickly mention some practical issues because they are relevant, I think, to the ethical consideration. And it's what I like to talk about under the rubric, the problems of calibration. And although Dan didn't fall into this, much to his credit, a lot of the talk about geoengineering relies on what I think are some pretty bad analogies, ticking bomb cases, for example, right? So it's as if the climate is going to explode, and so we had better have trained already, the elite squad of geoengineers to come in and keep the guy from setting off the bomb. But it's the very nature of the climate case that these turning points are going to be very difficult to predict. And in fact, by the time we're able to predict them, it may be too late, given the lag time in the climate system that Dan talked about so well. So in general, there's going to be a problem, I think, in trying to fit any attempt to geoengineer to the exact nature of the climate problem. And that's just one, in the first instance, in terms of timing, but also in terms of, the degree of change, where you want to set the thermostat. Okay, just two other brief things. One is just to say something, I guess, about that old paper, and then a quick concluding remark. When I wrote that paper, it was actually for a AAAS symposium in 1994. And more than anything, that paper was a plea for people to think about what norms should govern geoengineering. And what has disappointed me most is that while an interest in geoengineering has continued to take off in many ways, so the science is still quite undeveloped, as Dan points out, the interest on the part of some scientists is not undeveloped and is, in fact, growing. But the actual development of norms and principles for how to think about even what should govern research, much less what should govern implementation, seems to me to have hardly progressed since when I wrote that paper. And I think that's a problem for two reasons in particular. One is when you start getting markets in carbon offsetting, particularly when they're unregulated markets in carbon offsetting, and then you get some people who are claiming to do all kinds of things to offset people's emitting kinds of activity. I'm thinking about the Planetary case, for example, but other kinds of cases like that, iron fertilization in this case. You start creating strong private sector incentives for manipulations of the climate system in essentially an unregulated space. So we're starting to create the incentives for people to engage in geoengineering activities without having an institutional framework for regulating them. And in fact, the way that Planetary was knocked out was essentially under the London Anti-Dumping Convention, which in a way was completely, arguably irrelevant to the intention of the convention. But that's another story. The other concern that I have, at least about some geoengineering proposals, like the space mirrors thing, it goes back to the Edward Teller case. I mean, why do you think Edward Teller liked space mirrors so much? Well, you might remember Edward Teller didn't like Russians very much. And space mirrors, among other things, could actually cross that line between being an environmental intervention and actually being a way of essentially a weapon of war, both in terms of denying solar radiation to other countries, in terms of concentrating energy, and so on and so forth. So there are not always bright lines between environmental interventions and other political matters. Okay, then in conclusion, I just want to say this. If I can find the right scrap of paper. Yeah. Just this year I published a book. I mean, it's going to very vainly quote myself, and I think this at least initially chimes very well with what Dan was saying in part of his talk. I said, in my opinion, there are three broad scenarios for what the future may bring. Environmental catastrophe, 1. Continuing and increasing global inequality and environmental degradation, 2. 3. Or a change in the way of life of the world's most privileged people. Now that's a kind of trilemma, because we see the first two options as unacceptable, right? Environmental catastrophe and global inequality. But we see the third is impossible. Now, I think part of the attraction of geoengineering is the old attraction that often attaches to technological interventions to allow us to transcend the grubby world of politics and the depressing realities that we face. I think geoengineering in fantasy promises an escape, or at least a strategy for blunting this trilemma that I've described. But I don't think in the end it will work, in part because of the same issues of power, control, and ownership that make it so difficult to deal with mitigation will simply return to haunt us if we start seriously thinking about a global thermostat and who controls it. So I think in the end, and maybe this is pessimistic, there is no way to avoid environmental or political catastrophe except by taking this third option that we see as impossible, and that is changing the way of life of the world's most privileged people. Thanks.
Just about 10 minutes, so it's not going to be a lot of questions, but we definitely want you to ask questions. We have a roving microphone. You've got, so put your hands in. Tim over there.
Give a chair.
I have two questions. One is, can we realistically start testing climate engineering? A related question would be, does that change the ethics if we can test these? And then on a different note, is there an opportunity to geoengineer the increasing acidity of the oceans as well as the temperature?
So let me answer the technical aspects, and I'll let Dale discuss whether that changes the ethicality. Can you start to test it? Yes, you can test it on a variety of scales. You can inject aerosols into the stratosphere, and we've actually do that periodically when a volcano erupts, and we can measure the impact. Pinatubo was a nice natural experiment, and there are good observations, and we can produce better observations of what might happen. I want to make it clear, because some of Dale's comments were about things that are called geoengineering but not climate engineering. And I'm really specifically focused on something that will actually, on short time scale, deal with the fact that we may really be in trouble with climate change, and therefore will rapidly mitigate the problem. I should note, though, that there's good evidence that you can't keep doing it. It's not an indefinite fix. That is, the higher the greenhouse forcing gets, long-wave forcing by greenhouse gases is not canceled perfectly by reflecting sunlight. And so if it's a small level, it looks like the compensation's pretty good. But as CO2 concentrations grow and grow and grow, that compensation gets worse and worse, and the impacts probably become too bad. So this isn't a long-term, meaning millennia. It's not a long-term solution. It perhaps buys us some more time. It is possible to do some actual tests, putting aerosols in and having good measurements. But I don't think that actually fundamentally changes the questions about unintended consequences or possible feedbacks that you weren't expecting. The argument that I come to there is that those same feedbacks we're likely to encounter by raising greenhouse gases, and therefore I don't think they change either way, because they're there no matter what you do. Your other question was about the acidification of the ocean. Some people say, well, if you engineer the climate, you're still going to destroy marine life through ocean acidification. And isn't that a terrible thing and a reason that we need to reduce emissions and not do climate engineering? It turns out that there are possible ways of engineering that. I've actually published a paper on that. It turns out it's probably prohibitively expensive to do that, to artificially do silicate weathering, essentially. And you can actually imagine such schemes. We had an idea with essentially swaps a weak acid, carbonic acid, for a strong acid, hydrochloric acid, through electrolysis. But that's a separate issue. The truth of the matter is, though, if you care about marine ecology, the first, second, and third thing that is affecting marine ecology is overfishing. And we don't seem to give a damn about overfishing. So the reality is that I doubt the world is willing to spend the money to reduce carbon emissions because of ocean acidification. I wish that were the case. I've been to probably more coral reefs than anybody else in this room in different parts of the world, and unfortunately they're all dying. And acidification may be the sort of cruelest of these because even countries that have protected their reefs are going to suffer. But the truth is we have trashed the ocean. Take a look at what Jeremy Jackson has documented in terms of the destruction of the natural world in the last 3 centuries. The ocean is dead. We're talking about saving the dregs. And the idea that somehow there's this huge, we're going to change our behavior because of the last little bit, I think is naive, unfortunately.
Well, just to clarify, I mean, first of all, the debate often gets framed as against research or for research. I don't see it that way. I'm actually in favor of continuing research on geoengineering. What I'm not in favor of is a kind of Apollo-scale crash program for geoengineering of the sort that David Victor and others advocate in the current issue of Foreign Affairs. The other thing, what I would like to be kind of the ground level norm that we could all agree on, and I think maybe we could, although every time I say that people disagree, is that there should be no implemented geoengineering techniques except in the context of a broader mitigation policy. And I think if that were one of the governing norms for geoengineering, then the worry that some people have that geoengineering simply replaces mitigation would not be a concern.
I put that in the category of 2 of your 4, that's almost a given. You will not see it coming the other way.
Yeah.
Denise and Marion, and I think maybe all we have time for.
Well, the last comment actually links to my question, which is whether geoengineering might detract from efforts to mitigate. And policymakers will say, well, we're already spending X amount of money on geoengineering, and it's going to provide us with insurance or protection, and thus we don't have to mitigate emissions as much as you scientists are telling us we have to do. This is buying us time. We have the umbrella up. And they won't understand that it's an imperfect solution. There's consequences in the short term and larger consequences in the long term to doing this.
So the 2 of the questions that we talked about in this workshop up in Cambridge a year and a half ago were just that. 1, does this reduce the need to reduce emissions? Does this limit the need to reduce emissions? And 2, will it limit the need to reduce emissions? Which are different questions, right? And I think the risk is that it might, that some people will think about this. In fact, the Wall Street Journal has called this a techno fix.
I would actually change what you just said. It won't reduce the need. I think scientists would probably agree to that, but will reduce the perception of the need.
Yeah. Will it reduce, will it reduce the will to reduce emissions? Or yeah. And I think the answer is perhaps, although one of the answers to this, and this is where I actually think we need to embrace research. I would say not just we should allow research. I actually think we should dramatically encourage research, because my perception is that most of the research is being done by people who are advocates for this, as opposed to the people who I brought to this conference. For those of you in the climate community, people like Carrie Emanuel, Chris Bretherton, David Battisti, who had never worked on these issues before. But frankly, I really want those guys to think about what the consequences are. These are the best meteorologists, atmospheric scientists in the world. And if I frankly trust them much more than I trust some Livermore bomb designer to tell me whether or not the climate system has a problem if you do this. I think we need more research on this, and it will tell us. One of the important things was the point I made earlier. There is some indication based on one or two model calculations where you go from a doubling of CO2 compensated with aerosols to a 4 times CO2 compensated with aerosols, and the compensation doesn't look so good with 4 times. It looks pretty good with 2 times. But frankly, that's with one model that's pretty bad. It's pretty crude. We need much better understanding of the mechanisms, because if that's true, if you say you have a limited window over which you can do this, but above a certain threshold it really breaks down and the consequences become severe, I'd like to know that. And my suspicion is we will know that. But we have to also, that means if we're advocating research, be open to the possibility that maybe it really works well. I mean, what if it actually turned out to work really well? That has to be a possible outcome. Many people expect that we'll discover that it won't work. We might discover that it actually works really well, and we have to be open to that as well.
Yeah, just to...
Before you answer, let Marion ask her question. Okay. And we'll have that in the home.
So this is very selfish, but both of you touched on somewhat dismissively on ocean fertilization, and that actually is still very much a live issue, and there's still companies who think that they're going to make their fortune doing this. So if you could just expand on some of the ethical concerns that you raised with that, I'd be very interested in hearing them.
So I'll let Dale talk about the ethics, but I just want to say I don't think ocean fertilization works, period. And the reason is very simple. The argument for ocean fertilization, by the way, I don't think it's, the reasons have nothing to do, it's a different sort of thing than putting aerosols in the stratosphere and cooling the whole planet. At most, the people who've calculated it optimistically say it could remove 1 billion tons of carbon per year, which, we're producing 8.5. It's a marginal solution at best. It doesn't really change the trajectory all that much. But I don't think it even does 1 billion tons. I think it even doesn't even do 1/10 of a billion tons. And the reason is, the argument is, in the Southern Ocean or in the Eastern Equatorial Pacific, there's nutrient excess because you're iron limited. So you add iron and now you can use all these nutrients to take up carbon. The fallacy of this is that you're not thinking about this over several decades. Those nutrients in those regions, 30 years from now, are going to be drifting their way into the gyres where currently their nutrient limitation occurs. And a large fraction of that nutrients, essentially what you're doing is you're cashing in on nitrogen and phosphorus today that you would be using elsewhere 30 years from now. So it's not clear if you integrate over decades that you actually get much new additional carbon uptake. You may just be sacrificing some productivity some years hence. And I think that's not very well understood. So I actually just don't think it works. I think besides, it's no company's right to it's not clear who owns the phytoplankton in the middle of the ocean, but that's a...
Yeah.
Dale, why don't you wind up and answer both questions? The moral hazard, and
Right.
It's all a form of moral hazard.
That's right. So I guess there's 3 brief points. The first is, in a way, it's endemic of this area that, like a year ago, I was at a meeting of oceanographers who at least thought that there should be a whole lot more money for them to do research to see whether it works. I mean, which I think is kind of revealing of just it's a bit like the Wild West out here, I think, with a lot of these proposals. My biggest concern with all these issues, I think, is it's where science, technology, money, and political power come together. And I don't know whether iron fertilization works, but the threat of the planktos possibility is exactly because it's at that nexus. And that's where things start spinning really wildly out of control in dangerous ways. Now, one thing about the issue about big mission-driven research versus curiosity-driven research on geoengineering, which is the kind I'm in favor of. I actually think mission-driven research attracts advocates, both because once you start doing the research, then your interests become allied with the implementation of the technology. And I think the interesting analogy to look at here is something like missile defense, for example, where once you get a big research program up and going, the imperative to implement is almost irresistible at that point. I mean, scientists like to think that scientific research is completely distinct from questions about implementation, but the problem is, for fear of just putting it in the most condescending way possible, when it comes to the big decisions, the scientists get kicked out of the room and the adults decide what to do. And that's the real worry with these.
That Lowell Wood, who's the biggest advocate for climate engineering, also lied to Congress about missile defense. So the same people.
Yeah. No, I mean, it's like the climate change deniers. I mean, it's the smoking lobby all over again. And then finally, one worry I do have when people talk about things like like stratospheric sulfates as being cheap. First of all, we don't know that it's cheap because the economics of all this is also wildly uncertain, just like everything else. Another thing that tends not to get taken into account is that you have to sustain this for who knows how long, decades, centuries, who knows. And if you apply high discount rates, as economists do, that's part of why those calculations come out as being cheap. But when you tell policymakers that geoengineering is cheap, then it's not going to be surprising that they're going to think that looks like a more attractive option than serious
so many
mitigation.
things I would like to add, but I know we can't do it because it's past 6 o'clock. So let's thank our speakers.